Hello. In this video, we're going to be doing some preparation work to get ourselves ready to make structure and isopack maps. So in our previous videos, we had loaded some data, we constructed some cross sections, both in our petrophysical interpretation and in our .map window. Now we want to move on to making structure and isopack maps. Now, there are a few ways that we can do this. The first way that we can do this is through the CPI file. So I am going to just make a new petrophysical interpretation here. So I'm just going to say new petrophysical interpretation. Once again, I'm going to give this a name. I'm going to hit OK. And I can choose my well logs, headers, and tops. And once again, this populates my map. If I click on a well, it shows me my well. And if I wanted to just very quickly make a structure and isopack map, I'm working with vertical wells. I could come here to this window, click on the settings icon, say show property map, choose to make my structure map and what zone I want to make it for. And it will give me a structure map here. And I have some controls on this. For example, I can control the cropping. I can control the color palette. I could also set some custom contours if I wanted to on here. And that gives us a structure map for every zone here in our project. I could also make an isopack map here by choosing isopack. And, we can view these isopacks zone by zone. And if we see, like, for example, that we had here in the Parkman formation, that, there's probably actually something wrong here, and we see there's a well or two where, we haven't picked that lower Parkman formation, we could come here to our cross section, look at these wells, and we can, let's flatten our cross section here, and we see that we've not picked the lower Parkman everywhere. We could, pick that missing top because we've just told it to go top to top. I think there's probably a few over here at the end that we haven't picked as well. We could come in and finish picking our stratigraphy across these wells, and all we have to do now is click the refresh icon, and it will update the maps for us. Once again, it will have to pop open this jobs menu to regenerate that map because it's detected that there's been changes. And here in the CPI, when we do this, it uses the well log data, and it also is generating many other maps at the same time for all the zones in our project. So that's why this will take a few seconds here. Now, this is a way that we can come in and we can very rapidly QC our maps, and we could iterate on this process. We still see that we still have, problem area here where we haven't picked out the lower Parkman, so we could, come in. Once again, continue this evaluation of our stratigraphy here. And now we see we've got that lower Parkman picked across all of our wells. Once again, we could just refresh this. You'll need to run another job, but now we should see this problem on our isopack go away. So that's one quick way that we could get started. However, there may be situations where you need more sophistication, or where instead of doing this in the CPI, you want to make a grid file that is, a static file that can then be used in subsequent processes like our modeling. Now, to do that, there are a few things that we need to do to get ready for this. So I'm going to close the CPI so we can focus on those other tasks. So I'm going to make my project window a bit bigger here so you can see what we're doing. So here I've got my welcome project, and if we're doing gridding, we really need to do this in XY space. Now to work in XY, we need a projection. So what I'm going to do, I'm going to start off by creating a projection. And I do that by right-clicking here. I'm going to say Edit Projection and create a new projection here. And you'll notice it makes this file. Now we could just use our WGS84. However, if we want to work in XY, we need to choose our .prj. I'm going to choose a file here, and I've already got a projection file for this area. If you don't have one, we have those with the shape files and the example data, so you can just grab that. And you'll notice it gives us a little preview of it here. It says, okay, yep, we're using NAD 83, Wyoming East, it's in feet, tells us what datums and projections are being used. And you'll notice we have the little star here, which means it's not been saved. So we need to either go Control S or File, Save, and we save that projection. Then we can close that. The other thing that we probably want to do is we want to work using, when we're making isopac maps, we don't necessarily want to go top to top because we can run into the problems that we saw in the petrophysical project we had. When we go top to top, we want to use defined zones. To do that, once again, we can right-click here on our welcome project, and we can say Edit Zones, and it'll ask us to create a new zones file. We're going to do that. And here in this window, it'll now ask us if we'd like to initialize from tops, and we're going to do that. We're going to select our tops file, hit OK. And in this window, we now see that we have a list of zones. And we'll see the zones say starts at Lewis, ends at top of next zone. Teapot starts at Teapot, ends at top of next zone. So, since the top of our next zone is the Teapot here, so essentially it says Lewis to Teapot, Teapot to Parkman, Parkman to Lower Parkman, and so on. This will solve the problem of if we have some missing tops. Now it is specifically doing that calculation on the Parkman top to the Lower Parkman top, the Lower Parkman to the Sussex. Now, if you have unconformities and you need to have, for example, multiple tops or multiple bases, you could do that. You can say Edit, and I'm going to zoom out a little bit here so you can see the whole screen. And we could say End at Specified Top, and we could choose from a list of tops multiple tops here. So the Parkman, if this was unconformably onlapping onto this, maybe we'd want to say, Sussex, Shannon, and Niobrara. So we could set it up like that. Now that's not the case here, but in this case it would say, hey, I'm going to look for the Sussex first. If that's not there, I'm going to choose the Shannon. If that's not there, I'm going to choose the Niobrara. This is also a way that you can handle inconsistent tops picks in your zone of interest. I'm just going to say end at start of next zone here. Let's say I don't want to use my Lower Parkman here. I can disable this zone, or I can delete the zone. And if my zones are in the incorrect stratigraphic order, I could drag those into the correct stratigraphic order by clicking here on these 8 dots and by dragging this up or down. And then once I'm done, I need to save this by, once again, either going File, Save, or clicking Control S. So now we have our zones defined. Okay, what else do we need for making structure and isopac maps? Well, if we're dealing with deviated wells, we need to include our deviation surveys. And this is one of the areas where using our specialized tools for making structure and isopac maps gives you a quite a substantial benefit over using the quick maps made in the petrophysical interpretation. So first of all, we need to load our deviation survey, and to get to that, we need to go Help and Help Articles, and scroll down to the section for sample data, and then we'll say Deviation Survey Data, and if you click on that, it will download the file to your Downloads folder, and then we'll come back to here, and all we have to do is right-click on our Welcome project, and we can say Upload points. So any type of spreadsheet data can come in as points, and that's how deviation surveys come in. So we'll say upload points, choose file. I'm going to choose my deviation surveys, and I'm going to call this welcome deviations.points. You'll see that we have columns API, measured depth, inclination, and azimuth. Most of these wells are vertical, but we do have some horizontal wells in here, and we'll click OK. This will upload, then it will go running, and then finish. This will be very quick. Okay, so now that we've done that, we need to process our deviations. To do this, we come here to the example flows folder, and we're going to right-click on O1A process deviations and say make a copy. I'll call this welcome deviations, say OK. And now it's created this. I'm just going to drag it here into my welcome project folder. And it's asking me to select some data here. So I'm going to select my welcome deviations. I am then going to play match the columns, API to API, measure depth to measure depth. I'm going to choose my inclination and my azimuth. And then I'm going to give it an output name. And in this case, I'm going to choose welcome processed deviations. And then I can either click on the small arrow here to run, or I can go flow run. And that will run a flow. And this flow will process our deviations to give us the measured depth, the TVD, and the XY offsets of our deviations. Okay, and this should run very quickly. And once it's ran, we'll notice it creates a new points file called welcome process deviations.points. I'm going to click on that. It'll show us our points file here. Now most of these wells are vertical, but if I come over here to about the third page, we can start to see that we've got some deviated wells here. And here we can see a well that was drilled to the south. We know it's drilled to the south because our dy is negative, and we see that it's about 5,200 feet of offset there. And we can see the TVD on this well was about 9,000 feet, and the measured depth was about 14,350. Okay, so that is how we process those deviations. All right, so now that we have done that, we've set ourselves up by making our projection file, by bringing in and processing our deviations, and by creating our zones. We're now ready to make structure and isopac maps, which we'll do in the next videos.